Hello. I wanted to talk today about materialism again, I suppose. A bit more about how it's apparently, or I think, actually been refuted, and just to say a bit about the refutations. How do we know that materialism has been refuted, basically? Because I've talked about it a bit in previous videos, but I wanted to focus on materialism itself on this one, and just say a few words about it. The idea of materialism is that the physical domain is causally closed. That is, only physical processes and entities exist within the physical domain, and only physical causes can cause anything to happen. So physical forces, physical particles, that's it. This is, if you like, the default view of the hard-nosed scientist of past eras, or at least of the 20th century, let's say, and back a bit. And of the hard-nosed skeptics of today, who I argue are being a bit irrational because it's not backed up by science, in fact. But the idea of materialism is that effectively there are no non-physical outside causes to what happens in the universe. There's also no downward causality. All causality is upwards. That is, it proceeds from the forces and the atoms and the molecules, the quarks and gluons and what have you, that stuff is made of, upwards through the chain of complexity of matter, and not the other way. So, for instance, your mind, where you think, I'm going to go to work today, and so you get up and go to work. That has to be an illusion in materialism, because actually what they would say happens is the machine did it. Atoms and molecules bouncing around, phosphorus ions crossing membranes in your brain and stuff like this, actually made the decision, and your thought about it is an after effect. An epiphenomenon. The machine is dumb, it doesn't know what it's doing, it just does it, and you think you know and are deciding. That's an inevitable conclusion that materialism brings. So your subjective experiences are epiphenomena, as they're called. They are side effects only, and they have no causal input into the system at all. Things can be uncaused, as in quantum mechanics. Things can be completely random, but they cannot be caused by a non-physical thing, like a mind or a consciousness. In fact, some materialists would deny those things even exist at all. Not quite sure how they come to that conclusion, but anyway. But at a minimum, they would deny that they have any effect at all. First of all, I would say this is contradicted by evolution, or at least Darwin's theory of evolution by natural selection, because for our epiphenomenal mind to evolve and exist, it would appear to need natural selection to have operated on it. It's there, presumably, because it gives us some advantage in nature. And so, when I can look at some phenomena and work out A causes B, causes C, therefore I should do D to get what I want, I'm actually doing something. And not just some dumb machine is doing something. And furthermore, from the materialism point of view, if it's right, then these epiphenomenal thoughts could be just random. Why would they correspond with what I end up doing and appear to affect my behaviour? Why are they related at all to my behaviour? So I could be thinking, oh, I'm at the zoo, okay, and I can be thinking, oh, let's go and pet this tiger or lion on the nose, shall I? But actually my body will be running away. Because natural selection can only work on the physical, apparently, according to them. So our thoughts in a materialist universe, if they exist at all, wouldn't need to correspond with our actions at all. They could be random. But the fact they do correspond with our actions seems to me to suggest that they have a causal effect. Because why wouldn't they? In the same way as the reason children resemble their parents is because they've inherited characteristics from them, and natural selection works by selecting between inherited characteristics. So my thoughts are, okay, they're inheriting characteristics from my mechanical operations of my brain, or whatever. But there seem to be some feedback loops there, which materialism doesn't allow. Unless the thoughts are physical. But we can't detect thoughts or consciousness and things of this sort. We can stimulate the brain and get experiences to pop out, but we don't see experiences in the brain. And this is another issue in a way. People who say that the thoughts and the experiences are the brain activity are definitely wrong about that, it seems to me, because if two things are identical, they're the same thing, then they must have the same properties. This is a law in philosophy called the law of identity, I think. You make a list of properties of entity A and a list of properties of entity B, and put the lists in the same order, and if all the same items are present and no extra ones on either list, then the things are the same. But if the lists are different, then things are not the same. Well, the list of the properties of the brain is not the same as the list of properties of consciousness, or even the verbal mind, come to that. You can measure electrical activity in the brain. You can't measure electrical activity of consciousness or in consciousness. We can't detect consciousness at all. If I have a conscious experience of seeing a plant, where is the experience of seeing the plant in the brain. There's some electrical activity corresponding to that seeing, but that's electrical. So that the physical properties of them are, the listed properties are not the same. So I think that refutes the idea that consciousness is brain activity. Brain activity consists of chemical movements and electrical movements within the brain, but consciousness doesn't seem like that. Even though it's correlated, it has something to do with it, but it's not the same. There are electrical movements in a television set, but the program is not the same thing. It's something to do with it, but it's not the same. Another issue is materialism says that everything depends on the fundamental physical reality of the subatomic, subnuclear particles and forces. It has to be said we don't actually know what these things are. Matter and energy. And I would add that in quantum mechanics the fundamentals are events and the probabilities for those events to happen, rather than matter and energy, really. But even looking at matter and energy, we don't know what they are. We can figure out from Einstein that matter and energy are equivalent. They're the same thing. Matter is just another form of energy. So energy is more fundamental, if you like, or matter is, if you prefer, if you're keen on it. It doesn't matter which you choose. It's more convenient to talk about energy. When we look at the definition of what energy is, it's the ability to do work. So when we're looking at some little subnuclear particle and we say, it has an energy of 15 electron volts or something. It has 15 electron volts worth of ability to do work. We don't know what that is. We just know that it can do work. It can do something. We could use that energy to do something. If we dig down further and further past, I don't know, quarks and whatnot, they're theorized to perhaps be made of strings, which are vibrating rings of what energy? I don't know. They're vibrating rings of the ability to do work, right? It's not really physical at all. Whatever it is, it doesn't seem to me to be that the idea of physical actually is well established. When you dig right down to the bottom of matter, you find essentially nothing plus the ability to do work somehow. Bit strange. And of course, I mentioned quantum mechanics. Quantum mechanics is really these other refutations have been somewhat philosophical. Quantum mechanics is physics after all, and physical realism is the idea that reality is whatever physicists say it is, fundamentally. And that's an alternative to materialism, and physics is not consistent with materialism. It was abandoned really in the 1920s. Okay, people have taken a long time to catch up, and they're still catching up, but quantum mechanics is where it really counts in experimental terms. I've mentioned Bell's theorem before, and how Alan Aspect's experiment, the double slit experiment, and this lot have been manipulated with entangled particles to prove that there are no local hidden variables. So, just to summarise it again, you take two particles that are made in the same mini explosion in an atom, like two electrons emitted by an atom at the same time, so they're entangled with each other. You send them off in opposite directions, or somewhere away from each other, and when you observe, say, the polarity of one, or the spin of an electron in this case, of one, that immediately tells you what the spin of the other one is going to be, or it constrains it, even though they are too far apart for a signal to have got between them. And the Bell's inequality is a bit of logic or maths, which says that if there are hidden variables that we don't know about, in other words, if these electrons actually do have a state even before we've measured it, and we just don't know all the details, and that's why it appears to look like us, like it only gets defined when we look at it. If there are hidden variables, then the results will be different from what we actually get. The percentages of the correlations between the two will vary slightly. And Alan Aspect did that experiment back in the 60s or something, and found that there are no local hidden variables. It was ruled out. Bell's inequality was violated by the experiments, and you can read about it or see it on YouTube. So there are no local hidden variables. Now there's another inequality called Leggett's inequality, and Zellinger has been doing experiments, and he showed also that there are no non-local hidden variables. That is, they made sure that the electrons are far enough apart that they definitely couldn't communicate with each other. Previous experiments were maybe a little bit not properly constrained on that, but they did prove that there was no local component to it, no physical communication between them. But with non-local hidden variables, the experiment design is different. You have to prove that even if they are far enough not to communicate, there still can't be something else that we don't know, like non-causal communication between the two. Zellinger's also done a local delayed choice quantum eraser experiment, where you send the particles through the slit. Okay, so it'll either go through a slit or a pair of slits, and normally if you observe a particle going through a pair of slits, it will go through and be a particle, and if you don't observe it, it goes through but as a wave. And you can put a screen up and you get a wave pattern on the screen if you're not observing the particles, and if you are observing, you get just two straight bands, one behind each slit, because they go through as particles. But the delayed choice quantum eraser experiment is where you don't decide whether to observe or not until after the particle or wave has gone through the slit. When you do this experiment, you still get particles when you observe and waves when you don't observe. So in effect there's some backwards in time causality, because you make the choice after the particle has gone through the slit. And yet still the outcome is different. There's also the Kochen-Speckler theorem, which I haven't looked at these experiments, so I can't tell you about them really, but it demonstrates that the features that you're measuring don't actually exist until they are measured, which is a fundamental idea of quantum mechanics, and this experiment proves it. I'll have to have a look, I don't know it. Bazelling has also done a non-causal delayed choice quantum eraser experiment, in which he's made sure that although the choice is made after the particle passes through the slits, it's made so much at the last minute that no signal can get back to him, to the electron or particle, before it hits the screen. So it might be, I think he did it like from 144 kilometers away, so no light signal can get back in time to influence the experiment. It's non-local, in other words. He also did it from 55 meters away or something like that as well, but he went for big distances too. And again, it makes no difference. If you decide to observe, you get particles. If you don't decide, if you decide not to observe, you get waves. He's also done Leggett-Garg experiments, which show that the get-out some people use is that the macro level, big world that we live in, is built up out of quantum particles and stuff. So, but the two are separate, they're different, like all the quantum realities have collapsed at our level and we don't see quantum phenomena. Well, the Leggett-Garg experiments shows that actually no, you can do quantum experiments with big particles too, like molecules, little aluminium chips. They've managed to do wave particle duality experiments with. I haven't got up to doing big. I'd like to see what happens if you do quantum experiments with conscious creatures. Now that would be interesting. Very. These are interesting, but consciousness is where it's all at, isn't it, after all? Another way out of it is the many worlds interpretation of quantum mechanics. So instead of, when you observe something, this or that possibility happens, what they say is every possibility happens in a different universe, and the universe has to split every time. But when you do the maths on that, a single body contains 10 to the 24 quantum events happening every second. A human body, roughly. And the known universe contains, I'm guessing, about 10 to the 90 quantum events every second. So every second the universe has to split into, say, 10 to the 90 parallel universes to take account of each quantum possible event. And that's only when there are binary choices, like this or that. Some things are continuous, like the position of an electron around an atom. It can be any one of an infinite number of positions. So you have an infinite number of universes created. And every single one of those universes has to, every second, create its own swarm of universes for all the possibilities that can happen in that universe. And each of those has to, and so on. So essentially the many worlds interpretation, whilst not an impossible interpretation, it breaks one of the rules of thumb of physics, which is Occam's razor, that entities should not be multiplied unnecessarily, and you should use the simplest explanation for your experimental results. So creating an infinite number of universes effectively is Not a very simple explanation. It's a bit more understandable perhaps than the quantum weirdness, but it's highly uneconomical and of questionable science, because we can't really measure these other universes. There may be parallel universes anyway, but probably not caused by this process, because this process is just crazy, and crazier even, arguably, than quantum mechanics. So the upshot of it is that, anyway, if we accept quantum mechanics, is that conscious observation causes matter to become physically real, or for actual events to happen, or for matter to exist in specific states, rather than as a probability wave function only, or probability wave only anyway. And this is not consistent with materialism. They need to adopt quantum mechanics, and then their thinking will be rigorous again. One issue, though, with this is, if consciousness is needed to make things exist in a real sense, then, first of all, what was observing the universe before we were around, or any living creatures were around to observe it? You see that one tends to be led in a religious direction here. There may be some other way of interpreting it, but you can see the difficulty that scientists have with this. Okay, because they don't want to believe religion because there's a bad history with religion, okay, and science. They don't get along. Also, I mean, how do we know that we exist? Are we being observed? Because we have Schrodinger's cat experiment, where we stick a cat in a box with a bottle of poison, which is controlled by a random event generator, like a particle of radioactive stuff, which, if it decays, the poison is released in a bottle there, and the cat dies. If it isn't released, the cat is alive. We close the box and we don't look, and we ask ourselves, well, is the cat alive or dead? Now, if the cat doesn't count as an observer, then the reality hasn't collapsed. So we can look in the box and we can see, but our colleague across the room hasn't looked in the box. And although when I look at it, I see maybe the cat's still alive, but from the point of view of my colleague across the room, am I and the cat now in a superposition of states? Are both possibilities still real for the conscious creatures there? We need to do experiments with conscious creatures, maybe not fatal ones, ideally, to see if superpositions of state can happen with conscious creatures or not. I'd say that's like the next big thing that needs to be done in quantum mechanics. I think they've managed to do something with bacteria, but perhaps they're not conscious. And anyway, how come the universe was around before conscious creatures anyway? Who or what was observing that? Or is it something to do with this backward causality, the quantum eraser type of thing? And if a possible conscious creature existed in one of these superpositions of states at some point, bang, that universe became real. Could that be doing it? Could that have done it? Could a non-physical conscious creature have done it? Maybe, if consciousness is not physical in the first place. Maybe so. I think that would be something for philosophers to figure out. It sounds a bit doubtful to me, but something presumably has to observe this quantum universe to make it real, other than us, because we haven't been here all the time. So, puzzling one there. Let me know what you think in the comments, and I'll see you in another video sometime. Bye for now.